For our final type of problem, we have the most difficult type because we're going to have to deal with a quadratic equation. For this problem, a rock is thrown with a speed of 10 meters per second at an angle of 30 degrees from a cliff that is 20 meters high. Determine the time it takes to hit the ground below, how far from the base of the cliff does the rock land, and what is the max height that the rock reaches above the cliff top. So again, we're going to set our reference frame to be at the rock, and then we're going to set what is known and what we're trying to find. So our knowns is our initial y is 0 meters, our initial x is 0 meters, and then our final y is negative 20 meters. Now what we're going to have to do is we're going to have to decompose our vector again, which we can find our vx initial is v cos theta, which is 10 cosine 30, which is 8.66, and our initial y, which is v sine theta, which is 10 sine 30, which equals 5 meters per second. So what we're going to do is we're going to use our second y equation, which we've been using a lot, which is y equals y naught plus vy naught t minus 4.9 t squared. But in this case, the only thing that's going to cancel is our y naught. So if we plug in, we get negative 20 equals 5t minus 4.9 t squared. So we're going to set this up like a quadratic equation because that's what we have, and we need to have a 0 on the left-hand side. So we're going to rewrite this as 0 equals negative 4.9 t squared plus 5t plus 20. And what we're going to do is we can use the quadratic equation, or we can use a graphing calculator to solve this. And when we do this, we get t is equal to negative 1.57, or t is equal to 2.59 seconds. And since we can't have a negative time, we're going to get rid of this. So our time where it lands is going to be at 2.59 seconds. And to find the x displacement, what we're going to do is we're going to use our x equation, which is x equals x naught plus vx naught t. We know that this is 0, and we can find that it's just going to be our initial velocity in the x times time, which is equal to 8.66 times 2.59 seconds, which is 22.43 meters. And then to find the max height that the rock reaches above the cliff top, what we're going to do is we're going to use the third y equation, which is vy squared equals vy naught squared minus 19.6 change in y. And we know that the y, velocity at the max height, is going to be equal to 0. So this is 0, so we get vy naught squared equals 19.6 change in y. So our change in y is going to be equal to vy naught squared over 19.6, which is 5 squared over 19.6. And you see that we get 1.28 meters, which was the same that we got before. If we wanted to find the max height that it reaches above the ground, all we'd have to do is add the height of the cliff. So that would mean that the max height it reaches is 21.28